In this lesson, we're going to look at what are called transgenic organisms and answer the question, are GMOs a good or bad thing? So as a review, remember, enzymes are made of proteins and they control reactions. Plasmids are small pieces of DNA, circular DNA, that are only found in prokaryotes, and that genes code for proteins, and those proteins can create traits. So first, let's look at what a transgenic organism is. So the word genic means gene, trans means to move. So basically what we've done is we've moved a gene from one organism to another. So we have created an organism that has DNA from a different species added to it. And this is because we have actually added the genes. So an example of this would be a glowfish. So we have taken a gene that was in a jellyfish that creates a glow-in-the-dark protein, and we've inserted it into some fish, and so now we have glow-in-the-dark fish. So let's now look at the steps of creating one of these kind of transgenic organisms. And we're particularly going to look at a transgenic bacteria. So the first thing we got to do is we got to cut out the gene that we want. And what we're going to do this is use what's called a restriction enzyme. So these are enzymes that act like biological scissors. So remember we talked about how enzymes are like tools? These are scissors, and they can cut DNA. So here is my human chromosome. So let's say I'm trying to insert a human gene into this bacteria. So here's my gene, and here's my restriction enzyme. And what it's actually going to do is cut out that section of DNA so that I can then take it and do things with it. Next, what I'm going to do is I'm going to take that gene and I'm going to stick it into a bacterial plasmid, which remember is a small piece of DNA itself. So if this is my bacteria, this is the normal DNA, and this would be the little plasmid. So here I have my plasmid, and once again I'm going to use my restriction enzyme, and it's going to cut the DNA. So it's going to open it up, and then I can take my gene and actually stick it into this bacterial plasmid. And the reason why this works is because it doesn't matter if you're a human or a bacteria or whatever living thing, our DNA is exactly the same. So this human DNA can be stuck into a bacteria's DNA, and the bacteria's machinery, cellular machinery, will be able to read it exactly the same way. So next up, I have this plasmid that's got a human gene in it, and I have to get it into a bacteria. And a bacteria that has taken in this plasmid, we call this a transformed bacteria. And that's because we have transformed it into a unique organism that has never existed before on Earth. It is a bacteria that has a human gene in it. So it's a new organism. So here's my bacteria, and here's my plasmid with the human gene, and there's various techniques to do this, but I'm going to get that plasmid inside that bacteria, and it has now become a transformed bacteria. Alright, and then finally what I need to do is get that bacteria to start making the protein. So I have this transformed bacteria, it's got this gene, now it's going to start doing transcription and translation just like normal and expressing this gene, and is going to make the protein that I want. So if we look at this all together, here I have my gene, and I'm going to cut it out with a restriction enzyme. Then I'm going to use the restriction enzyme to cut my plasmid, and I'm going to insert my gene into it. Next, I'm going to take that plasmid and I'm going to get it into a bacteria and turn it into a transformed bacteria, which can then use its ribosomes and other enzymes to transcribe and translate that gene into the protein that I want. So why do we go to all this trouble to make a transgenic bacteria? Well, those new genes that I've added create new proteins, and those new proteins can be things that I really want, like medicine. For example, insulin. If someone is type 1 diabetic and they have to take insulin shots, that insulin was actually created by a transgenic bacteria. So all of those people have this transgenic organism to thank for being able to get the insulin that they need. In previous times, that just wasn't the case. And then agriculture is full of transgenic organisms. But we don't call them transgenic organisms, we call them GMOs, or genetically modified organisms. And you've probably heard a lot about GMOs, but you probably don't know all that much about them. So let's look at GMOs really quick, and then you guys are going to look at them a lot more later on. But why do we make them? Well, for one thing, we can take genes and insert them into crops to make them more resistant to pests. So we have to use less pesticides, and we have fewer crops get eaten or killed by various pests. We can insert genes that make them more drought and heat resistant, so we can grow them in more places, and we're less likely to have a heat wave or a drought affect our crop. We can actually put genes in there that will help increase the nutrients, so we can help potentially fight malnutrition in third world countries or even here in the United States. And finally, just at the end of the day, we need to be able to grow more crops. As human population increases, the need for food increases, and somehow we got to be able to make more food.